What if the third visitor from another star wasn't just a comet, but something built? For 6 breath-holding hours, the solar system turned to Mars as its only eye in the dark. While Earth's instruments slipped behind the sun and went silent, a glowing emerald object raced past the red planet at nearly 28 million kilometers, flashing in perfect pulses, drifting as if nudged by an unseen hand. Astronomers call it 3-Eye Atlas, the third confirmed interstellar traveler. But this wasn't like the icy drifters we've seen before. Its green halo burned too bright. Its chemistry was upside down, and every burst of light came with a tiny jolt in its path, as though something inside was steering. For a brief window, all the secrets of that strange visitor were locked inside the view of just 3 Mars orbiters. The question that kept scientists awake was simple. Was this a freak of nature, or the first engineered object ever caught crossing our solar system? When the countdown hit 0, the strangest twist wasn't what the object did, it was what Earth couldn't do. Our best telescopes and probes went silent, not from a glitch, but because of simple geometry. For the next 6 hours, the sun lined up between Earth and the object's path, blinding every instrument we had. In that moment, Mars became the solar system's only watchtower. Every probe circling the red planet, MAVEN, Mars Express, and ExoMars TGO, turned all its cameras, spectrometers, and sensors toward the emerald glow streaking past. Engineers knew there was no second chance. If anything strange happened during that blackout, only these 3 spacecraft would see it. Inside control rooms on 2 continents, teams known as the Red Watch took over. They were the operators trained for emergencies, the ones who ran decision ladders for every possible surprise. In those tense hours, they rehearsed lightning-fast instrument switches, from routine science mode to burst mode spectroscopy, ready to react to a sudden flare or a wave of debris. Every command was double-checked, every packet of data copied twice. Bandwidth was rationed down to the minute so no sensor went blind. On Mars Express, image sequences were trimmed to the bare essentials, stacked together to catch even the faintest sign of the object breaking apart. TGO's spectrometers combed the coma for chemical fingerprints that shouldn't be there, while MAVEN's particle sensors listened for ripples in Mars's thin ionosphere, the kind that might reveal something interacting with the planet itself. The pressure was crushing. If a burst of dust threatened the orbiters, they'd have to sacrifice science and shut down to survive. One wrong call, and humanity would lose its only window into a visitor from another star. But even as the control rooms raced to stay ahead of the comet's unpredictable behavior, the data that did come through began to show something no one expected. The first images looked beautiful, almost too beautiful. Instead of the dusty gray haze typical of comets, 3-Eye Atlas glowed in electric emerald green, like a neon lantern hanging in space. The color wasn't just striking to the eye, it didn't fit the chemistry we know. Spectrometers showed that the usual water vapor signature of a comet was barely there. Instead, the coma was loaded with carbon dioxide, 8 parts CO2 for every 1 part water. No comet in our solar system has ever shown a ratio that extreme. Then came the pulses. Amateur astronomers were the first to spot them. Bursts of brightness arriving like clockwork. They rose sharply, faded cleanly, and repeated in near-perfect rhythm. Not the jittery, chaotic flares that normally come from sun-warmed jets of gas. It was as if some invisible switch was flicking the glow on and off. More surprises followed. Alongside the emerald halo, instruments detected unexpected nickel lines outshining iron, the opposite of what any comet textbook would predict. Even the dust was wrong. The particles appeared larger, slower, and strangely well-behaved, drifting in wide, graceful arcs instead of the usual ragged jets. Individually, any one of these quirks might be written off as a rare fluke, but together they started to paint a picture that didn't belong in any familiar category. Scientists compared notes, hoping one anomaly could explain the rest. Instead, every new dataset seemed to deepen the puzzle. And then came the detail that made researchers sit up in their chairs. Each brightness pulse seemed to coincide with a tiny nudge in its path, a micro-acceleration, as though something inside was steering its course. Whatever was racing past Mars wasn't behaving like ice and dust blown by sunlight, and the strangest part was still to come. From the outside, 3-Eye Atlas looked like a drifting emerald snowball, but the closer the data came in, the less it behaved like one. Each burst of green light was mirrored by a subtle jolt in its trajectory, a shift too small to see with the eye, but large enough for precision instruments to register. It was as if the visitor was tapping invisible thrusters in sync with its heartbeat-like pulses.
Ordinary comets don't move that way. Their path changes when jets of gas erupt randomly from sun-warmed ice. Those flares come in fits and bursts, messy and unpredictable, but Atlas's nudges arrived with a kind of rhythm: on pulse, drift, on pulse, drift. Even the dust tail betrayed a strange order. Instead of spraying in chaotic streaks, the grains seemed to fan out in wide, measured arcs, like handfuls of sand tossed gently into water. The arcs held their shape far longer than models predicted, almost as if the particles were being released in carefully timed bursts rather than blasted out by solar heat. Scientists tried to fit the motions into every natural equation they knew: sunlight pressure, sublimating gases, even Mars's weak magnetic field tugging on charged dust. None of it lined up cleanly. For every model that explained one feature, another detail slipped through the cracks. In private messages and late-night calls between mission teams, one question kept resurfacing. Not as a conclusion, but as a whisper. Was something guiding it? No one dared say the word engineered aloud at a press briefing. The rule was simple: extraordinary claims needed extraordinary proof. But the data kept bending the rules of ordinary comets. And just as Atlas skimmed past Mars, the real battle wasn't in space, it was in the control rooms. On 3 continents, engineers hunched over glowing consoles, headsets pressed tight, their voices clipped and tense. The countdown clock on the wall wasn't just marking time, it was measuring their last chance to catch the truth before the object slipped beyond reach. The Red Watch teams, specialists trained for unpredictable emergencies, had been rehearsing for weeks. Now it was all real. One wrong decision, one software hiccup, and the window would slam shut with nothing to show but static. Every spacecraft above Mars had its own role in this desperate relay. MAVEN aimed its ultraviolet spectrograph at the emerald coma, searching for sudden outbursts or fragments breaking away. Mars Express stripped its imaging plan down to seconds-long snapshots, stacking them into rapid-fire sequences that could reveal tiny changes in shape or brightness. ExoMars TGO locked its spectrometers onto the visitor's thin atmosphere of gas, hoping to snag even a whiff of an unfamiliar chemical fingerprint. The orbiter's power and data budgets were stretched to their limits. Commands were scheduled down to the minute. Who could transmit when, which instrument could draw extra power for a few seconds, and when a probe had to shut down a camera to save its batteries for a high-priority scan. On the ground, the room was a picture of controlled chaos. One group tracked the comet's path in real time. Another filtered raw telemetry for signs of debris spikes that could threaten the orbiters. If the density of dust climbed even 30% above the safety limit, they'd have to send a safe observe command, shutting down instruments and turning the spacecraft shields towards the oncoming cloud. It would keep the probes alive, but end the science run. Outside the official network, amateur astronomers around the world stood ready, feeding their own light curve measurements into shared databases. From Pune to Patagonia, backyard telescopes pinged servers every few minutes, hoping their readings might back up or challenge what Mars was seeing. For 6 hours, every passing minute felt like borrowed time. A single glitch could erase humanity's only close-up view of an interstellar visitor that was rewriting the rules of comets. And all the while, the object kept flashing in its hypnotic emerald rhythm, as if daring the watchers to figure out what powered its strange dance before it was gone. When the first wave of data came in, the mission scientists did what they always do: start with the simplest explanations. No one wanted to jump to exotic conclusions when physics and chemistry might still hold the answers. The leading theory pointed to deep cold origins. Somewhere in the farthest reaches between the stars, so cold that even water freezes out early, carbon dioxide could dominate. A comet born there might carry far more CO2 ice than water, explaining the bizarre 8-to-1 ratio. That idea fit part of the picture, but not the clock-like pulses or the synchronized jolts in its path. Others proposed volatile pockets hidden beneath the surface. As sunlight seeped into the crust, trapped gas might erupt in sudden jets. If the layers were arranged just right, they could vent in a repeating cycle, making the comet appear to flash in rhythm. Laboratory models showed it was possible, but not with the near-perfect regularity Atlas displayed. A third camp blamed unusual dust dynamics. Heavy, carbon-rich grains could drift slowly, their release shaped by solar wind or even Mars's weak magnetic field tugging on charged dust. Again, the timing just didn't quite add up.
And finally, some argued the anomalies were simply holes in our models. With only 2 other interstellar visitors ever observed, every new one tests the limits of our simulations. Maybe the pulses and microaccelerations were the messy byproducts of physics we don't yet understand. Not a sign of intent, just of our own ignorance. Still, for all the careful reasoning, there were moments in late-night calls and hushed side conversations where a different thought surfaced. Could nature alone choreograph a performance this precise? No one put engineered on an official slide. The rule held: extraordinary claims demand extraordinary proof, and proof was still missing. But for many watching those synchronized pulses in the data stream, the line between rare natural outlier and something else had never felt thinner. As the debate raged, the clock kept ticking. The window was closing, and the teams knew the final verdict would have to rest on what the Mars orbiters caught before the Emerald Traveler slipped back into the dark. When the blackout lifted and Earth's instruments blinked back to life, 3i Atlas was already gone, a fading emerald spark sliding back into the dark. All that remained were terabytes of Mars-based observations and the questions they couldn't settle. For the first time in history, 3 orbiters and 2 rovers had acted as the solar system's lone observatory, capturing over 40 hours of high-cadence images, spectra, and particle data. The public didn't have to wait long. Raw telemetry was pushed to open archives within hours, a move that broke decades of slow-release tradition. Anyone, from university researchers to backyard astronomers, could scroll through the same data the mission teams were parsing in real time. That data confirmed some things. The emerald glow was real, not a camera artifact. The carbon dioxide-heavy spectrum stayed stable even as the object neared the sun. The nickel-rich signature persisted across multiple instruments. But the 2 most unsettling clues, the synchronized brightness pulses and the tiny course-correcting nudges, refused to fit any single natural model. The best explanations still felt like guesses, and no simulation yet links the light and the motion in a way that satisfies every dataset. The encounter changed more than just the science. International protocols shifted overnight. NASA, ESA, and JXA agreed to mirror data servers, rapid-release anomaly flags, and shared pipelines for citizen science uploads. Amateurs from Pune to Patagonia were now officially wired into the early warning chain. Planetary protection boards rewrote chain of custody rules for dust and ice grains captured during interstellar flybys. Despite all the progress, the verdict on Atlas itself stayed split. The conservative camp still sees an extreme but natural outlier, a comet sculpted by exotic chemistry in the deep cold between stars. The extraordinary camp argues that the precise timing of its pulses and micromoves deserves a harder look. Officially, the final report closed the case with unresolved anomalies. Unofficially, many researchers admit that the object left behind more mystery than certainty. One thing is undeniable. Atlas changed the playbook. Future interstellar visitors will face a planet better prepared, faster with data, more transparent with findings, and ready to capture every fleeting clue. And yet, as the emerald coma faded into the void, a single question lingered on every mission log. If this was only the third visitor we've ever seen from beyond the stars, what might the fourth one bring? For centuries, we've looked at comets as frozen leftovers from the birth of stars, ancient, predictable, harmless. 3i Atlas broke that illusion. It reminded us that space still has surprises big enough to change the way we think about our own solar system, and maybe about what might be moving through it. The scientists who watched those emerald pulses still don't agree on what powered them. Was it a trick of deep space chemistry we've never seen before, or the first faint hint of something designed? The data doesn't settle the argument, and maybe that's what makes this encounter unforgettable. What's certain is that we'll never see Atlas up close again. It's already on its way back to the dark between the stars, taking its secrets with it. But there will be a fourth visitor one day. When it comes, our instruments will be sharper, our questions harder, and our curiosity deeper. So here's the thought to leave you with. If the next interstellar traveler flashes the same strange signals, will we recognize the pattern in time? What do you think powered those perfect pulses? Rare physics or something more? Drop your theories in the comments. Your idea might be closer to the truth than anyone expects.